Hello everyone, welcome back. So in this video we are discussing about the memory based questions of MPSC exam of assistant professor and associate professor computer science and engineering, computer science basically, which was held on 13th Feb 2026. So one of the question was based on this topic called as lattice, which is under discrete mathematics, that which of the following diagram is not a lattice. So one is chain, one is hexagon. I don't remember the rest two diagrams, but yes, this was the concept and the question was like that. So you just need to identify which one is not a lattice. One more question was there is high page fault activity in operating system is called as, it's a direct answer called as thrashing. Okay, so most of the questions are like where you need to know the basic concept. What is thrashing? Okay, you know the what is thrashing, where it comes in operating system or a compiler or a computer organization, then you need to know the concept. That's it. One question from operating system was like this, that you need to apply shortest remaining shortest job first or shortest remaining time first algorithm, and you need to find out the waiting time or average waiting time for this three process. So here you need to do some calculations. So that was the one question where you need to do some calculation. Then the other question was like based on the networking. I don't know whether it was a rigorous, strict or basic two-phase locking protocol, but they have given, or conservative. So they have given some rule or condition or description, and we need to find out which one is two-phase locking protocol, whether it is a strict, rigorous or conservative, something like that. So that was one question. Then there was another question that what you called in a TCP ICP layer, the application layer packet was there, or datagram unit, or the last layer which is a network layer. So they just asked whether it is a datagram unit, whether it is a frame, whether it is a packet, what you called. So I don't remember the exact question, but it is related to this topic, which is TCP IP model. And there are just 4 layers. So they have said that if it is a datagram unit in a transport layer, so what it is called in a network layer, or what it called in application layer, something like that. One question was this was the exact same question for cyclic redundancy check. Exact same question. Now I know this question, but the problem is you need to do all this calculation to get this message to be transmitted. So this is the thing you need to find out, but to find out this thing you need to do this complete calculation. So I mark that question particularly, that I know the procedure, that I know what we need to be done, but I will do it at the end because this is a lengthy procedure, as you see. So I mark it, but by the time I reach, it was already 60 minutes and I didn't mark this question, but I remember this, it is the exact same question, and then this is the answer for it. So I'll be coming up with the detailed solution once the actual paper is published on a website, which is not published yet. Then there was a direct question again for a pumping lemma. There are these 3 conditions given, and the 4th option is obviously all of this. What are the conditions for pumping lemma? And obviously 1, 2, 3 all should be the condition for the pumping lemma. So I have done this preparation through this last minute notes from the Gigs for Gigs. So you can also find this on Gigs for Gigs. Let me go for the next question now. Okay, so one question was there with this memory hierarchy or a cache memory, that if it is a hit or if it is a miss, what should be the total or average or effective access time. So you need to calculate the effective access time by using this formula or the concept of cache memory or memory hierarchy. Then from from digital electronics or digital circuit, there were few questions where the circuits are given and you need to find out the final expression. So there was some question like what should be the equivalent of this gate, or what should be the final result of this gate. So another question was there based on the number system, like which one of the following is 2's complement is equivalent to the same number or something like that from digital circuits. Then for finite automata, there were few questions like for based on the regular expression, based on the Turing machine also, and in finite automata there were few questions. Another question was direct question like which of the following shows the correct sequence of a stack. Like first you performing or push or pop, what you will do. First whether you will check for the condition like overflow or stack is full, and then you will increment or decrement the top pointer, and then only you will pop or do. So this was the sequence, like first obviously you will check for the condition whether the stack is full or overflow, and then you will push or pop the element, and you will change the top pointer. So this was a question, a direct easy question. Then there was this where the master theorem is used. It's used in a divide and conquer. And there was also a question based on this formula where you actually apply the master theorem and find out the time complexity for that particular uh, equation. Okay, so there were two questions based on this topic. Then there was this question like what is the minimum number of comparison required to find the second largest element in a list of n numbers. So these options are given where they have changed the plus and minus sign, or instead of log n just n or like that. So this is again a direct question which was there, but I didn't know this formula earlier. So but yes, this question was there. Then there was a question like a direct question, which of the following is an injective function, whether it is one to one, one to many, or like that. So it's one to one, that is again a direct question. So these are the questions that I remember so far. Okay, one more question was there from a digital circuit or logic is if you are multiplying 3-bit binary number, two 3-bit binary number, how many output you will need. So it is actually a 6-bit and 6 outputs you need. And I just thought it is an adder or a subtractor. So I just thought, okay, one for addition and one for carry, or one for a subtraction and one for borrow, like that, just 2 output. But actually when you are multiplying, you need based on how many outputs you have, like 6, or if it is a 3-bit, obviously you are going to get 6 outputs, something like that. So this was the another question. So these are the questions that I still remember from the MPSC examination. As I told earlier, I'll be coming up with the detailed solution for each and every question, so as soon as the paper is released, or at least the response sheet is released from the MPSC website. Thank you and stay tuned.